Okay, family, this is the solutions, or these are the solutions to the free response portion of your practice test. I did have to make 2 additional flashcards for these problems, and the first one applies to this first problem. In order to do this first free response, you need to use the expected counts formula. So the expected counts formula is used when two variables are independent. It's used to find the inside values of the table, and this is the formula. Now, where this is in your notes is at the very end of categorical data. So if I go in to my categorical data, the last thing that we did was expected counts. And then right after that, you should have all of the different ways that you can compare two distributions. So to compare two distributions, you can do 2 separate bar graphs. You can do side-by-side bar graphs, so that's where you take each category and put it next to each other. Or you can do the two different complete bar graphs next to each other. I know that that's not a very great description, I apologize, but these are all of your different options, including your segmented bar graph. So these 2 papers, if you weren't able to get started on number 16, should help you with number 16. And then, like I said, I needed to add in a flashcard for this idea. So that's your expected counts formula. So this tells you that there is no relationship between these 2 variables and wants you to find the inside values. Well, first you have to find the missing value. So hopefully this one wasn't too hard. You just take 120, subtract 10, subtract 70. That tells you that 40 was supposed to go there. And then here you just do 120 minus 42, and 78 is supposed to go there. So then if you go through and do this formula, row total times column total divided by table total, this gives you the counts for the inside of the table. And if you go through, it really works. Like 24.5 and 45.5 add up to 70. 14 and 26 add up to 40, 3.5, 6.5 add up to 10, and it works this way, the column way, vertical way too. So that is all based off of that formula. The next thing it says is, find the conditional distribution for the explanatory variable. Whenever age or gender is one of the variables, those are always explanatory. So age and gender, always explanatory, which means that if you're drawing an arrow, he starts at the age group and curves down to the preferred method. This arrow is reminding you that when you find your conditional percents, you do it this way, meaning you divide each one of these categories by 42 and each one of these categories by 78. It does not even matter what is over here in this table total. So if you go through and do that, what you find is that it doesn't matter what your age group is, the same percent of people prefer the method of communication in that category. So let me make that a little easier to understand. It doesn't matter how old you are. 58% of the respondents said they prefer text. It doesn't matter if you're old or young. 58% said text. Doesn't matter how old you are. 33% said call. 8% said write. So this reinforces what the problem began with. There is no association between age group and preferred communication. These variables are independent, meaning your age group does not affect your preferred method of communication. Now, Famil, this is not real life. My mother still writes letters. Puts little sticker emojis on them. I'm always going to the store looking for sticker emojis. Anytime I find sticker emojis, I buy them and give them to my mom because she still writes people letters. Apparently, she has a lot of feelings and needs a lot of sticky emojis to be putting in her letters. That's besides the point. I'm just saying, I'm pretty sure, and by pretty sure I mean sure, that your age group does affect how you would prefer to be communicated with. My assistant coach for cheer, she's 21. She always wanted to be FaceTiming me. I do not want to FaceTime. That's weird. Why I gotta FaceTime you? Why isn't an audio call good enough? Once again, besides the point. I'm just saying. Then lastly, it says make a graphical representation of the conditional distributions. So I chose doing the two different categories in their own bar chart. So I did 58, 33, 8 for the old group or old category, 58, 33, 8 for the young group. These could have been right next to each other. So that would have looked, I feel like that would have looked weird. So these two bars would be right next to each other, the same color. These two right next to each other, same color, same here. And I would draw it for you, but then I draw over my key, which kind of bums me out. Or you can do a segmented bar graph. I can do that one for you. A segmented bar graph would look like this. What's the other one? 8? Don't worry, fam. This will only take me a second. So this is what your segmented bar graph would look like. This is your text. Next one is your call. Last one is write. So your segmented bar graphs look exactly the same. Or you could have done two completely different bar graphs. So one bar graph for the old, one bar graph for the new. Just remember if you do it, not new, young, just remember if you do it that way, your bars should not be touching. Okay, so as long as I'm remembering correctly, you have roughly 3 free response questions on your exam. None of them are this long. None of them really go through because you can't, there's no way you could answer 3 of these in an hour and a half. So you would get like 2 of the parts. They would ask you to do A and B or B and C. You probably are not going to go through and do all of these on your unit test. On your AP exam, you have 1 question that is long like this and several questions that are shorter like the gavel problem. Okay, number 17, once again, you will not have a problem that requires you to do this much, but you will see the ideas in this problem from start to finish in your test. So what are the individuals? It's the brand X batteries and the brand Y batteries. What is or are the variables? The lifetime of the battery. You go through and put these in your calculator. You have to be really careful to make sure that you're reading your stem and leaves correctly. So in order to get this into your calculator, you go to Stat 1, and then I put mine in list 1 and list 2. Remember, if you need to clear a list, you hit clear. Do not hit delete. So if I arrow up, if I want to clear out list 3, I'm going to hit clear and enter, not delete. If you hit delete, it's going to just completely get rid of list 3. So both of the STEM plots have 15 observations. You can see them on mine. I will arrow down. So if you need help with what the stem and leaves meant. And then to get these values, and by values I mean to get the summary statistics, you hit stat, calc, 1, mine's on list 2, so enter, 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 and this is all of the information for this column. So before I even write my response, I know that I can use some of these to compare the distributions, because that's your next question. And you for sure gonna compare the distributions on this test, so please bless that you feel okay about it. So I know by comparing the mean and the median, if I'm unsure on the shape, this will tell me. So I was pretty sure that brand X was roughly symmetric and that these were just outliers. I was thinking that brand Y was right skewed and these were just outliers. Well, I was right on brand X. The mean is 392 and the median is 390, so that's roughly symmetric. But turns out, because of these observations on the lower end of brand Y is left skewed. How do I know? Because the mean is less than the median. So this is left skewed. The next thing that I compare is the medians, because if one of them is skewed, you compare median. So this tells me that brand Y typically lasts longer than brand X. And then down here, the next thing that I am supposed to address is the spread. So I like to use both. I like to say the data varies more in this one and then give the IQR. So the range tells me that brand Y varies more than X, but brand X has a larger IQR. So now I'm going to use all of these things that I know from this table to answer the question. So the distribution of battery lifetime for brand X. Now notice I am starting with the distribution of and whatever the x-axis would be. That's battery lifetime. The distribution of battery lifetime for brand X is roughly symmetric. And it's not symmetrical, family. Lots of you guys write symmetrical. It's not symmetrical. It's just symmetric. While for brand Y, it is right skewed. Brand Y batteries typically last longer than brand X. Their medians are 430 and 390. You have to use the word center or median. Battery life varies more for brand Y, from 170 hours to 330 hours, but brand X has a larger IQR, 100, versus only 60 for brand Y. Brand X has potential outliers on the upper end at 450 and 550, whereas brand Y has potential outliers on the lower end at 170, 220, and 260. Now, I went through and actually calculated using 1.5 times IQR, and it turns out these are outliers. These are not outliers. If I knew that, then why'd I include it? Because look at this problem, fam. We're not even done yet. And look at how much work we've had to do. There's no way in a test situation I am going to do 1.5 times IQR unless I had time. So I would only have done at 1.5 times IQR if I had leftover time on this test and wanted to go back. Otherwise, you eyeball it. So that's what I did. Okay, give a reason why someone might prefer brand X. Well, if you look at brand X, they're, in my opinion, pretty reliable because their distribution is symmetric. And if there are outliers on the upper end. So I said all of the batteries lasted at least 300 hours with unusual lifetimes on the upper end. Brand Y has 3 outliers on the lower end, so you risk getting a shorter lifetime than any of the brand X batteries. So for me, it's a risk to buy brand Y because you could end up getting a higher battery lifetime, but what if you're one of the people that gets one of these batteries? None of these batteries last as long as all of the batteries, or any, I should say, any of the batteries in brand X. So I think brand X is less risky. Why would somebody choose brand Y? While there are a few outliers on the lower end of the distribution, the brand Y batteries lasted at least 420 hours. Typically, brand Y batteries last longer than brand X batteries. It's more of a risk though. You risk getting one of those lower battery lifetimes, but if you don't get one of the lower ones, you actually get a battery that probably is going to last longer than the other brand. Get used to this kind of question. In fact, I would say the biggest takeaway from this battery question is answering E and F. They will always ask you to use your logical thinking skills and form an opinion about something. So why might somebody prefer brand X? Why might somebody prefer brand Y? So for me, the biggest takeaway would be this: be prepared to have an educated opinion. Okay, next up we have the gavels. How is this graphic potentially deceptive? There's so much wrong with this graph. But the first thing is, I don't know where the x-axis even begins. Like, is it at the bottom of the gavel or the bottom of the red dot? So that's an issue, but the even bigger issue is whether it starts at the bottom of the gavel or the red dot, it doesn't start at 0. The typical distance or the typical scale is this right here. This represents 1 on this y-axis. So there's no way that from here to here is 18, because it would need to be 18 of this, 18 of these, because this is 1 on this scale. And that, like, from 16 to 18, it is about 2 of these. From 15 to 16, notice that the distance is very similar. So just comparing the distance between the top of the gavels, I'm pretty sure that the Y values do not start at 0. But the even bigger issue is that the handles are diagonal, and that gives the impression that the differences are bigger than they really are. This gavel, the diagonal, is probably more than twice as long as this diagonal or this handle on the gavel. This is 19, this is 24. So this one should not be looking twice as long as this one. So overall, we're not starting at 0, and with that, not starting at 0 and having the handle be diagonal, that is what is making the differences look bigger than they really are. Okay, next up is find the median. Explain how you would find the median. So the first thing is you need to make sure that you understand how to read this histogram, and that's what this little box is trying to get you to do. So this bin that I have selected right here is telling you that 2 of the eastern states have a pupil-teacher ratio of 12 students for every 1 teacher. So 4 of the states had a ratio of 13 to 1. 4 of the states had a ratio of 15. 12 of the states had a ratio, sorry, I said that backwards. 4, 13, 4, 14, 12, 15. So it is important that you know what the bins are telling you. Now, above each one, I made sure to highlight the number of observations because that's how you find median. So, you must state, if they ask you to find the median of a graph, or tell them, sorry, let me re-say that. If they ask you to describe how to find median, what they are expecting you to say is that you know the median is the value for which half of the data is below it and half of the data is above it. So if you did not or do not write the sentence that I'm about to highlight, you would get partial credit on this, even if everything else was right. You have to say what I just highlighted in green. The median is the value for which half of the observations in a data set are below it and half of the observations are above it.
Monica Lazaro, please come to the Cypress main office. Monica Lazaro to the Cypress main office.
So now I describe how I'm going to do that. I can use N, the number of observations, to determine where the median is located. Then I can use the histogram to determine which bin has the observation I'm looking for. So for the West, it has 24 observations, so the median will have 12 observations below it and 12 observations above it, half of the data set. So half of 24 is 12, half of the data set below it, half of it above it. So the median must be between the 12th and the 13th observation. The 12th and the 13th observation is in the 15 bin, so the median for the West is 15. Make sure, Famil, that you clearly state the median. It is not enough to say the 12th and 13th observation is in the 15 bin. You have to somewhere clearly say the median for the West is 15. Now notice, since I explained it pretty good on the West histogram, I can just refer to it to find the median for the East. So I'm going to say the East has 26 observations using the same method described for the West. I know that the median is between the 13th and 14th observation. The 13th and 14th observation are in bin 15, so the median for the East is also 15. So when they ask you to describe something, because they will, in any case that they say, hey, describe how you would find this, if you have to do that more than once, just say, using the same method I described before, so that you don't have to write all that out, because you'll run out of time. You will run out of time, and this is not the only unit where they ask you to describe how you do something. So describe it thoroughly for one, and then just say, using the same method, and find the rest. Hopefully that makes sense and is helpful. Okay, fam, last question. They give you two histograms. They tell you the mean of each histogram. And typically they would say compare the histograms. So if you need help with comparing, this is a great question to practice. If you need help comparing histograms or comparing anything, you could use this problem as practice. Okay, back to the problem at hand though. They say, for some reason, we leave 18 teachers out, and now we want to put them back in. So we have 18 teachers we did not include that had a mean of 2.5. So their teaching year was 2.5. What is the mean of all 218 teachers? So 200 teachers had a mean of 8.2. They give that to me in the prompt. And then these random 18 teachers that we didn't include for some reason had a mean of 2.5. So now we got to find the overall mean. Well, I worked backward because I know that I can't just add these and divide by 2. That don't work. That do not work. And you also cannot just add them. You have to work backwards so that instead of having one mean being divided by 200, or sorry, one sum, and the other sum being divided by 18, you are dividing by the total of 218. So I found the sum of the ages by using this formula, and you've done something similar before. So all of the, oh, I don't think I meant ages, did I? I think I meant the sum of the years, not ages, the teaching year. Because a 2.5-year-old is not going to be teaching, and neither is an 8.5-year-old. So the sum of years for the histogram was 1640. So that means to get to get 8.2, they took 1640 and divided it by 200. Same here. To get 2.5, they took 45 and divided it by 18. So all I did was multiply these. 200 times 8.2. 18 times 2.5. Why am I multiplying them? Because that's how you solve this equation. If you want to get rid of a number in the bottom of a fraction, you multiply by that number. So these go away and you do 200 times 8.2. Multiply by 18, those go away. So you do 2.5 times 18. So now we can just add those together. The sum for all 218 teachers is 1640 plus 45. And now we can divide by 218, and this gives me a mean of 7.7. Now we haven't talked about the mean a lot because we're going to do that in your next unit. We're going to talk about the mean quite a bit. But I did have to make one last flashcard for this, and it was just really easy. I just have mean is the same thing as average. It's denoted, or the symbol is X bar, and it's the sum of the observations divided by the total number of observations. And unfortunately, in statistics, they very rarely give you an easy problem. They very rarely say, find the mean of this data set. What they often do is make you use your knowledge of what the mean is to do something else. So that's what you're seeing in this problem. Okay, that's it for the multiple choice. Let me give you a little bit of guidance on what you will see in terms of length of the question. So it is reasonable to think that you will get one. So these three are all the same length. Like these are shorter free response questions. These are considered shorter ones. But these two are really, really long because you have to do so many different parts. So for your exam, I would plan to have 3 of the shorter ones. One might be a little bit longer, but you're definitely not going to get 2 of these. At most, you would get 1 of these and 1 short one. Or like 2 short ones and then half of this. So just know that you'll be expected to do about half of what you have for practice. And then for the multiple choice, you'll have 10 instead of 15. And once again, any ideas that you don't feel great on, at this point, you're probably going to want to let them go and focus on all the things that you do feel good about. Unless you're super behind, then you got to catch up. In terms of studying, hopefully you're not watching this at midnight the night before your exam, but if you are, that's better than nothing. So good job. But I'm hoping that you have a significant amount of time to go through your flashcards. Make sure that you know your flashcards. What does that look like? You literally are going through, okay, what's the expected counts formula? Think of it in your head. Flip it over. Yeah, I was right. Okay, what's the mean? Think of it in your head. Turn it over. And you do that until you know all of them. Eventually, I start breaking them up. So once I know them, I take them out and I only go through the ones that I don't know. And then once I know those, I put it all back together and go through them. And you should change the order up. Once you know them all, switch them around a little bit and change the order up so that you're not just used to the order in your brain. You actually know the concept. So flashcards, know them before your test, because that's the only way you'll be able to answer all the questions. And then feel good about these. You don't have to feel good about all of them, because if half is passing, then that indicates how many you should really feel good about. You should feel really good about at least half of these. But make sure that you feel good about them. Once you feel good about these, flashcards is where it's at, family. So make sure you feel good about these questions. Go over your flashcards. It might take an hour, 2 hours, 4 hours, maybe 4 hours. But guess what? That is less work you will have to do in May when you're studying for the whole big exam. Okay, that's it. I'm done preaching. Love you guys. If you have any questions, send them to me. Come see me. Do what you got to do so that you can be successful on this test. Do your flashcards, I beg you. Okay, love you.